Welcome to episode 213 of the Actual Astronomy Podcast. This is going to be another deep dive. It's been a while since we've done one of these, eh?
Yeah. So we're going to spend some time just talking about what to observe in a number of different constellations that are prominent right now in the spring sky. We always do our monthly episode of what kind of a what's up or what to observe, but that one usually has more of a solar system focus. So this one will be more deep sky stuff.
Yeah. So I'm Chris. The other guy talking is Shane. We're amateur astronomers who love looking at the night sky, and this podcast is anybody else who likes going up into the stars. So I'm excited. I see Libra is on the horizon now when it's getting dark. However, it's getting dark later and later each night, unfortunately.
Yeah, it's a double-edged sword, isn't it? It gets warmer, but then darkness starts to elude us a little bit, and it's challenging. But it is exciting to see Libra. Is there anything that you're hoping to observe in that part of the sky?
Maybe a few things. Libra is pretty exciting because there's some globular clusters and that down there. There's some, that's sort of the leading edge. Libra used to be part of Scorpius, of course, used to be one of the claws. So, and the neat thing about Libra here, maybe the bad thing about Libra here is that we only get this really small window at the very end of April and to the maybe the first few days of June to see it when it culminates at about 12:30 or so. You barely get it in a dark sky, because that portion of the sky is the portion of the sky that's typically highest or very close to being highest when the sun is just over the northern horizon here. So we're pretty much into perpetual twilight when it's up, but there are kind of these brief, almost minutes when Libra does culminate in a dark sky, and you do get that happening around this time of year for a very, very short, maybe 5-week period of time or something like that.
Yeah, and folks that are further south than we are, we're at about 50 degrees latitude. The further south you go, the better views you'll have of Libra. Further north you go, it's even worse.
Yeah, it's a neat time of year though, because and for me it's a little bit of a cosmic desert because I really like to observe large extended nebulae, and there's not many this time of year to be able to see. So
yeah, there's a lot more galaxy observing and some clusters out there, but the big extended nebulas, we got to wait a little while.
Yeah, so maybe we'll start there. That's a good segue. I don't know if you intended that or not, but what is a galaxy just generally, Shane? And what do we see through a telescope when we see a galaxy through binoculars or a telescope?
So galaxies are a big collection of dust, gas, dark matter, stars, and millions to trillions of stars, but they're all bound together gravitationally. So when we look up at the night sky, we see a whole bunch of stars. Those stars are pretty much exclusively a part of the Milky Way galaxy. They don't extend beyond that. Now, there are some galaxies that we can see naked eye, like the Andromeda galaxy and a couple others. But typically, the world of galaxies, or the realm of galaxies, I guess, is visible through optics. You typically will want a telescope to start to really pull those in.
Yeah, the one thing that I always think about when I think about galaxies and sort of their description is, Immanuel Kant's theory of the island universe, or his, I guess, writings about the theory of the island universe, which was based on some earlier astronomers' observations. And it was William Herschel's observations after Kant came out with his island universe sort of quote that kind of solidified his sort of early ideas. Of course, his ideas wouldn't be proved out until Edwin Hubble and the Cepheid variables, which you had mentioned in the past episode, which Hubble observed, I think it was in the 1920s, through the Mount Wilson Observatory telescope. But anyway, yeah, like those galaxies are just basically congregations of stars and dust and nebula all on their own, all kind of packed in together into a very tight region of sky that we see. But for the most part, everything that we see and with our eye and for the most part with binoculars in our night sky, that's our own galaxy, eh?
Yeah, yeah, and I remember, Chris, when kind of earlier on in my my amateur astronomical career, if you want to call it that, that was like when I got that realization that the stars in the sky are not like all spread across the universe, that they are just our galaxy, and there's a whole bunch of other galaxies out there with more and more stars. It really is a humbling thought, right? Of just how large the universe really is.
Yeah, it's pretty wild to think about. And at this time of year, it's an interesting time because we can see both many galaxies, because we have the Virgo supercluster is culminating on the meridian on these evenings, and that gives you an opportunity to explore some of the really big and bright galaxies that are in like a whole other region of the universe, kind of centered in and around M87, which I think you can probably see M87 with good binoculars from a really dark site. Anyway, it's pretty easy in a small telescope. And then that whole region of like Markarian's chain, and then there's certainly other galaxies around. But then also we have some open and globular clusters that can be seen as well. And you kind of referenced these a little bit, but Shane, what is the difference between an open and a globular cluster? Maybe we'll start there, and then we'll get into some of these constellations.
Yeah, there's quite a few differences, but maybe one of the similarities is they are a collection of stars that are all gravitationally connected somehow. They're interacting upon each other gravitationally. Globular clusters got their name because they sort of look like a globe. Like they're typically like a roundish in shape, very dense core of stars. In a globular cluster, there's usually hundreds or thousands of stars, and they are typically the oldest stars that are in the galaxy. Now, open clusters, in terms of shape, are the exact opposite. They have no defined shape. Open clusters can represent anything. It's just, again, a grouping of stars that are gravitationally interacting upon each other. Open clusters are usually smaller in terms of how many members they have, probably in the tens or dozens to hundreds of stars are in an open cluster. And these are usually younger stars that are new to the galaxy. So there's a whole bunch of globulars in the sky that we can see, and there's a whole bunch of open clusters in the sky that we can see.
Yeah. And so what do they look like through like a small telescope, like what you and I typically use, like 3 to 5 inch instruments? Like what does an open cluster look like, and what does a globular cluster look like?
Yeah, so globulars for smaller telescopes will just look like almost like a comet, if you've ever seen one of those. It'll look like sort of just a round, fuzzy puff of light out there. Globulars usually benefit from more aperture. If you have an 8-inch Newtonian or something along those lines, that's when you can start to pull out like individual stars. And it's kind of fun. Like if you have larger aperture, if you look at, probably the most famous cluster in the Northern Hemisphere is M13, the Great Hercules globular. It's fun to try to count how many individual stars you can actually observe at the eyepiece. But anyway, in smaller aperture, like what you and I observe with, it's usually harder to pull out the individual stars in a globular. Now, open clusters, this is where smaller telescopes can really become the desired telescope to use, because open clusters are often occupy a larger part of the sky. So you need a wider field of view to take them all in. Smaller telescopes can give you much wider fields of view. And because the stars aren't all packed together, it's quite easy to count the stars and see how many are out there. And it's kind of fun too with open clusters, like in, say, the Pleiades, probably, arguably one of the most famous open clusters. It's fun to look at, how many of those stars are actually double stars, and the color differences of the stars. It becomes quite interesting. But as for patterns with these open clusters, again, there's no two that are the same. They're very unique, and you sometimes kind of draw your own lines and create your own shapes that you see within an open cluster.
Mm-hmm. Yeah, and one of the other sort of neat or maybe a little bit strange things about them, the globular and the open clusters, are that the globular clusters hang out like in the halo, sort of above and below the galactic plane of the Milky Way. So if you think about the Milky Way galaxy, it's kind of like maybe like a record or an old car hubcap, where it has sort of that bulge in the center, and then it kind of is thinner, around the disk. Sort of floating above that hub and below the hub are the globular clusters, whereas the open clusters tend to hang out closer to the plane of the galactic disk. It's just part of their makeup. All right, let's move on and let's chat. We'll do a brief overview of the main, pointer constellations, pointer stars and constellations, and then we'll talk a little bit about Hydra and its nearby constellations. So, in the springtime sky, Shane, we often talk about arcing to Arcturus. Mm-hmm. We talk about finding Boots the herdsman by finding the Big Dipper, and then you use the handle of the Big Dipper to arc down to Arcturus, and then to speed onto Spica. So we have a set of sort of these main constellations. So first of all, we have Orion and Gemini and Canis Major and Canis Minor kind of setting over in the western sky. And as they exit, we're kind of left with sort of Castor and Pollux and Gemini sitting up there, and maybe a couple of the other winter stars. But then kind of Leo and Virgo are taking center stage as Arcturus and Boots are rising pretty high in the nighttime sky. But do you use like the Dipper and those sort of pointer stars, or how do you find your way around this springtime sky?
Yeah. Sometimes I do, particularly the Arcturus. It just seems to, when I do that, it cements where I am in the sky, and from there, the other stuff is quite prominent. One of the other things that I do is I look more for the asterisms than sometimes the constellations, because I find sometimes the asterisms just stand out a little bit more for me. So, within Ursa Major, the Big Dipper is actually the asterism there. Within Leo, the sickle, or the sort of a backwards question mark, really stands out for me there. And then with Gemini, like once you get to know Castor and Pollux, like they're twins, they're very prominent stars that look identical. And, that's another grounding, I guess, or a way that I kind of get grounded in the night sky at this time of the year.
Yeah. And that's similar to how I do it as well. I really do find that Gemini, at this time of year, those twins, they really look like the twins. This, to me anyway, this is the time of year that Gemini really takes on its namesake of being kind of two, sort of very, like stick people, I guess maybe is the best way to put them, like two stick people in the sky. And that's really what they look like to me, because as that constellation rotates around, at least for us here where we live, they're kind of standing up. And then, like you said, Leo is sitting right on the meridian. And I find the pattern of Leo, as I scan across the sky and I find Regulus, which is the brightest star in Leo, then, as soon as I see that pattern stands out. Sometimes the pattern stands out first, but like you said, that sickle backwards question mark, and then the triangle. Although I really don't know what it looks like. It doesn't really look like a lion to me, but that's a unique pattern of stars, eh?
It is. Yeah. And it reminds me more of like the Sphinx, sort of, like a lion sort of sitting on its front paws. But the thing too with Leo that I'll mention And this is, you and I have talked about this a little bit in previous episodes about the scale of the sky compared to like a star chart. And Leo is one that even now, like when I look at a star chart and I look up at the sky and see Leo, Leo is really large. And I don't find too many star charts actually capture that scale very well for me. And maybe it's just a me thing, but Leo does occupy a large part of the sky.
Yeah, you're totally right there, and that's the one thing I try to convey. Like I was just saying before we recorded, going to start teaching my astronomy class in about 3 weeks' time, and that's one of the things that I always go over with people. Like, you know, when you're looking at the little chart or your software or whatever, the thing that the charts struggle to convey is that scale, because things in the sky are huge. And we've talked about this before many times for people that have listened to the show, is that your fist at arm's length is 10 degrees on the nighttime sky. And when you're using a chart or software in that, like where is that scale, right? You want to make sure that, that's one reason why you and I prefer to use pretty big fold out paper charts, because the scale is always the same and it's set to more or less that kind of ratio. It makes it quite a bit easier for learning the night sky. And honestly, Shane, I think you and I have both seen this, where people come out with their planetarium software and they're trying to look for a constellation, but they've got the whole night sky represented on the planetarium software, and so all the constellations are tiny. They're like maybe a centimeter or two if you held your phone up at arm's length, and then that constellation of Leo is I don't know, like 30 or 40 degrees across or something. So it's maybe 10 or 100 times larger on the night sky. It's very difficult to kind of parse the information that your phone's giving you and then relate it to the actual star patterns on the nighttime sky, isn't it?
Yeah, absolutely. Yeah, and it's not like an insurmountable thing. It does catch me sometimes, and you get used to it pretty quick once you actually start looking up at the stars and relating them to the star chart you're looking at.
Yeah, I find Boots, the herdsman, doesn't look like a herdsman to me. It just looks like this giant kite. Yeah. And Arcturus is this super bright orangish star. And I find that it looks, to my eye anyway, it looks so different from any other star. I can almost just look at that star and say, that's Arcturus. And then I kind of very quickly then see that kite pattern. But unlike Leo and unlike Boots, Virgo sits between these two constellations. But to me, it doesn't really look like much of anything. Like, in the pattern that I have up on our screens here, Shane, I got to say, I don't really see much of a pattern at all. Typically, I just see Spica, and then maybe 5 or 6 sort of almost seems like random stars sort of scattered around in that region of the sky. And basically, I know that that Spica is at the bottom of equilateral triangle, more or less, between Arcturus, Regulus, and then Spica sort of forms this upside down peak, more or less. And that's kind of how I navigate that zone of the sky.
Yeah. The Virgo part of the sky, like other than Spica, there's not a lot of prominent stars there, although once you get familiar there, it does jump a bit more. But yeah, agreed. It lacks the visual representation of what Virgo is supposed to be. I just see a few stars with sort of a bit of a line, and then I don't know, a jut out to the left, sort of. But
yeah. And it doesn't really look like much of anything. It's supposed to look somewhat like the female form, I suppose, but certainly don't see that. And then kind of sort of above and again in between all these constellations is Coma Berenices, which doesn't really look like anything except for a right angle triangle, which is, I find that one sticks out really prominent. And then we have the Coma Berenices cluster Malad 111, which is a huge open cluster, which sort of almost sits directly between like Arcturus and sort of the top of Leo there, and is pretty prominent in that region of sky. I think, even though it doesn't really look like much on the star charts, I think that's one of the more interesting regions.
Agreed. Yeah, for sure it is.
Yeah. So let's now that that's kind of the orientation. We have these main patterns, Ursa Major, your arc to Arcturus. You stay on that same arc to get down to Spica, and then you can kind of keep looping up and to the right, which will get you to Regulus and Leo, or you can find pattern of Leo, which is and Gemini, which are the ones that we tend to find, and then kind of work your way around. But just almost straight down and a little bit to the west of Leo is Hydra, which again, I don't know, what do you think Hydra looks like?
Yeah. Well, part of this too is we don't see all of Hydra this far north, but it doesn't look like much, right? There's just some stars and a line. So I guess in a way this does represent a serpent. It makes sense to me, but it is really just a bunch of stars that cover a huge part of the sky. In fact, what is it, like 7 hours of right ascension Hydra covers?
Yeah, something like that. But it is one of those ones that you do kind of have to trace out, and there's some interesting stuff to do with Hydra. So one of the things that I like with Hydra is that it kind of wraps around, or maybe snakes around, slithers around perhaps a pile of different constellations, and that's sort of Cancer, which is on its northwesterly tip, and then it goes by Sextants, and then it goes by Crater and goes by Corvus, which bracket it to the north and northeast a little bit, and then to the southwest we have Pyxis, Puppis, and Antlia, which is pretty neat. So you have this really large constellation kind of wrapping around the spring sky, and then in and around it, I guess except for Puppis maybe, all these other constellations are actually really small constellations, aren't they?
Yeah, they are, especially relative to Hydra. They're quite small.
Yeah, and Hydra really is big. Like it starts at about 8 hours, or just a little bit over 8 hours of right ascension, and it finishes just over 15 hours of right ascension, and it spans from -30 to almost +10. So it basically does sort of hug, for us anyway, that southern extent of the spring sky, and kind of as the spring sky begins to set, it kind of sort of tips up a little bit. So there's at one point, and we can see it all here from where we live at 50 degrees north. But there is like that point as we get into later spring where it's sort of like this huge line across the southern sky for us anyway. And those sort of fainter stars, that's Hydra. But one of the neat things that I find anyway, Shane, is that because all these bracketing constellations, or all these bordering constellations, are all pretty small. One thing that I've done in the past is remember those really wide angle binoculars that we had printed out?
Yep. The 2x42s or whatever they are.
Yeah, and basically what they do is they just give you kind of like super eyes, right? They collect a little bit more light, but they only take you down like a couple magnitudes or something like that.
Yeah, and exceptionally wide field of view. Like probably 20 degrees, I think, is what we calculated it at, or 25. I can't remember.
Something. It gives you a really wide field of view, like your fist arm's length. That's about 10 degrees. Most binoculars have between like 5 and, say, a really wide field pair might have 8 or 9 degrees. But these have at least 20 degrees, maybe a little bit more than that. And one spring, what I was able to do, this was just, I think the year we made them up, because we made them up in the winter. I was really excited to use them. I remember when I went out one early morning, one frosty morning, and I was like, I want to test these out, and I want to look at some stuff. And I actually scanned through, and I went from like Cancer, and I looked at M44, the Beehive cluster, and then kind of scanned down. And I could see like huge tracts of stars, and that head of Hydra, which has like this sort of weird little funny, almost like pentagon type pattern. And then I could see kind of the trail of stars, and could pan through and see like Sextants, and then like you can see like the whole constellation of Sextants and a huge portion of Hydra, and then you could pan over and see all of Crater and like even a portion of Hydra and Corvus in the same field of view, and then you can see all of Corvus in the same view and some of Hydra, and it's really neat to take those and to pan along that constellation, because I think sometimes people maybe wonder why would you make such a binocular that just is a huge field of view but doesn't really collect much more light. But it does sort of bring in some of these sort of fainter patterns, sort of like some of the lesser known or less popular constellations. Anyway, it's sort of a neat use. I'm not sure what you think of that.
Yeah, they're incredible. They're extremely fun to use. They're great for viewing, constellations or just the Milky Way, like sweeping large parts of the sky. And yeah, really what you said here is they're almost ideal for like kind of that Hydra region.
Yeah. So Hydra is a Greek constellation, and it's based or an adaptation of a Babylonian constellation of a serpent, which was represented in the Mall Appen. But there is a Greek tale, no pun intended, because here we are talking about a twisting snake, and some of the Greek myths. So one myth associates it with a water snake, that a crow served Apollo in a cup when it was sent to fetch water. So Apollo, what was happening was this crow was a servant, I guess, of Apollo, who's one of the Greek gods, and Apollo had sent the crow to get some water. And anyway, the crow tried to pull the wool over, the crow tried to pull the wool over Apollo's eye, saying that something happened with the snake anyway. But Apollo saw through the fraud and angrily cast the cup and the crow and the snake into the night sky. Kind of, I guess the crow tried to blame the snake that it didn't get the water or something like that. Hydra is also associated with a monster of many heads, the one that killed Hercules, and can be represented as other constellations as well, I suppose. But according to that legend, if one of the Hydra's heads was cut off, two more would grow in its place. So, however, Hercules burned out the roots of the heads in order to prevent that from happening again. But it's kind of neat to think about sort of this, that little head of Hydra and all these sort of smaller constellations around. I mean, you can almost sort of imagine the sky kind of depicting all those sort of different multi heads, perhaps, of the snake there, eh? Maybe,
yeah,
perhaps a little bit.
Sorry, you broke up a little bit.
Oh, maybe you can imagine that a little bit. Small constellations are a variety of heads for the Hydra snake.
Yeah, no, for sure. It's an interesting tale.
Yeah. The brightest star we have there is Alphard, and fairly interesting star to look at. It's sort of this orangey star once you actually look at it through the telescope. And in Arabic, it means the solitary one. There's not many bright stars in that region of sky, and it's a fairly bright star. It's a little bit fainter than Spica, but really not much when you think of that region of the sky as not having many bright stars, but that's one that you can see from the city, and really can help kind of guide your way around this zone of the sky, because there are not many bright stars in any of these constellations, really.
Mm-hmm, mm-hmm. There's a lot of interesting stars in Hydra. A pile of doubles. We don't have the time to get into to all of those. But there's also a really interesting variable there. If you don't mind, Chris, I'll just take a minute to talk about that. So it's R Hydrae. So I'm just reading out of Phil Harrington's book, Touring the Universe Through Binoculars. So
Tuba.
That's the name of the star?
No, Tuba is the abbreviation for the book. Everybody calls it Tuba, Touring the Universe.
Yeah, that makes sense. So what Phil wrote here is R Hydrae is one of the easiest long period variables for amateur astronomers to observe. Sharp-eyed observers have been known to spot it without any optical aid. as it rises to fourth magnitude or even brighter every 390 days. Binoculars display it as a dazzling red beacon when near its peak. However, when it cycles downward, it bottoms out at around 11th magnitude. So some binoculars would still pick that up. But anyway, that's pretty exciting. And that's a huge swing of magnitude, to go from 4 to 11. And, something that is kind of neat, right? Because it's 390 days. It's something that you can, come back to and observe over the season to see how it changes.
Yeah, that's really neat. I was just looking up to see if that was a carbon star, but I can't find it. Might be a Mira type star, looks like. Anyway, yeah, there's another one. I thought maybe it was the one I observed, but I think it's V Hydra, which I observed, which is the carbon star. I knew there was one of those ones up there that I take a look at pretty frequently. Any other ones that kind of struck your fancy there, Shane?
Maybe I will just read one of the doubles here. Just trying to pick one out real quick. This would be Struve 1273. So it's actually a quintuple, but that's only using spectroscopic observing techniques, but it is a visual triple. So it's a very dark field. The 3 stars that you can see visually are magnitude 3.5, 6.7, and 12.5. So the 12.5 is starting to push the limits of smaller telescopes for sure. So you may not pick out all 3 depending on what aperture you're using, but that one is kind of interesting. And like I said, there's just a pile of them. And if you have the Cambridge Double Star Atlas, the author, who is, what is his name again? Bruce McAvoy and Will Tyrion. They have a list at the back of all of the doubles that are plotted in the atlas, but they put stars beside like kind of the prominent ones, or like the real showpiece doubles. And in Hydra, there's got to be at least half a dozen of those sitting here. 2, 4, 6, there's 8 actually of those. So if you're a double star observer, there's a lot to see in Hydra, and I really recommend the Cambridge Double Star Atlas to guide you through there.
All right, sounds good there, Shane. Let's see, kind of moving along. If you go sort of, it's just like going to be a bit of a random tour, I guess, but at the very sort of easterly end, or getting towards the easterly end of Hydra, and I guess this object I'm picking kind of first-ish is because it's pretty bright, and it's one of those messy objects that people often miss because of the brief amount of time it's well placed above the horizon, and that's the galaxy M83, which is a really bright spiral galaxy that you can see in like binoculars and small telescopes. But again, because it only culminates for this brief period of time, like whatever it is, like 6 or 8 weeks, you really got to get a good night to be able to see it. And sometimes, like many years, I never get to see it because between when the snow melts and maybe getting some poor weather and then finally getting around to get out, maybe I forget to look at it one night, or it's behind a tree or house or something, then that's it. I often go for a few years without seeing it, even though it's such a fantastic face on spiral to take a look at it. Do you have any good memories of seeing M83?
Yeah, it's a fantastic galaxy. The memory that I have, though, is not wonderful because, like you said, it's very challenging for us here. And that, if I remember correctly, I think that was my most challenging Messier object, just because of the very short window you have to find it.
Yeah, but what it shows in like a decent 12-inch telescope is like these beautiful spiral arms, and you can actually start to pick out some of the star forming regions, which is quite fantastic.
Yeah, to be able to do that visually, like that is not there's not many galaxies you can do that with. So that M83 is a real showpiece.
Yeah, it's pretty low on the horizon, and in fact, if you're able to get further south, kind of at this time of year, then you can kind of use M83 as a bit of a guidepost to being able to find things like Centaurus A and some of the those showpiece Centaurus objects. Kind of make your way down from M83 to take a look at those. But of course, those are like literally at the horizon or just below our horizon here, and even from the ocean side, half a dozen degrees further south, I was never able to see any kind of hints of Alpha Centauri or anything like that down there. But some of the other things that you can see are M48, which is like sort of a sparse open cluster. And then M68, which is a globular cluster, which is actually quite a nice large globular cluster, which is just a little bit to the northwest of M83. So those are some pretty bright and different types of objects. So you get a bright galaxy, you get a bright open cluster, and you have a bright globular cluster. And to be able to see those all in one night can really be an interesting observing session.
Yeah. And for anybody that is, of similar latitudes that is working on their Messier list, make sure Hydra becomes a priority for you, because you just don't have a lot of opportunity to pull out all of the objects there.
No, and then one of the brighter planetary nebulas in the sky is in this region as well, which is the Ghost of Jupiter planetary nebula, and that definitely is worth hunting down. Boy, I remember when I saw that when I was observing at this person's farm. They had like the farmhouse that they had bought from, when the farm was sold. They didn't own the farmland around it. But I remember when I was in Ontario, I was observing the Ghost of Jupiter sort of from this person's back lot spot that they had set up for observers, but nobody ever used it. And I remember going up there and observing this one night and just being really surprised that I observed for 10 or 12 years before I ever looked at the Ghost of Jupiter. It was really neat to see.
Mm-hmm. It's a super cool object. I haven't looked at that for a long time. If we get out for some dark sky observing, I think I'll make that pretty high on the list.
Yeah, I think all of these are pretty neat, because I haven't seen that one in a long time either. Just because, and one of the reasons why I did want to get a different site is that in the spring here, the spot that we usually go to has that huge line of trees just to the south, and we can't see much from 35 degrees above the horizon to the south down. So we've sort of been missing some of these objects, because the other sites that we have are too muddy. This site isn't muddy, but it's it just doesn't have a great south. But anyway, my site has a pretty good south. A Bell 33. I've never seen a Bell 33, which is the reason why I put that in here, though. It's this beautiful ghostly nebula, almost looks like a blueberry or something like that. Have you ever seen that or heard of anybody observing it? I think I've seen observations and sketches through like 16 or 18-inch telescopes, but I've never taken a look at it myself.
Yeah, no, I've never looked at it, and no, that one doesn't stand out as anything that I've seen through another person's telescope.
Yeah. And then we have the globular cluster NGC 6535, which is like a sort of a broken apart globular cluster. Let's see. So kind of moving on from Hydra, and actually right above the head of Hydra, we have Cancer the Crab, which is a pretty neat constellation. It's small, but I find it's very distinct because it almost has, I think it's like is it like a gamma symbol or lambda? Maybe it's a lambda symbol, something like that. Looks like an upside down Y. And I feel like that's really what it looks like there, right?
Yeah. That's a really good description. I've never really thought about that, but you're right. It does take that shape.
Yeah, and then just almost right at the center of like where all these points cross for the Y, we have Messier 44, or the Beehive cluster, which is one of the best open clusters in the nighttime sky, which is really cool to look at.
Yeah, it's great, especially like binoculars or real wide field. It's wonderful.
Yeah, that's definitely like a binocular gem or real small telescope kind of gem. But Cancer itself, goes back to about 2000 BC, described as a scarab in Egyptian records, and the Babylonians, they saw it as a snapping crab. So this probably dates back to some of the earliest times. And then, of course, just to kind of go a little bit deeper on the beehive. One thing that's neat about the beehive is it was also known as praesep, which is Latin for the manger. And I believe, if I recall this correctly, this was perhaps the first object that Galileo publicized in his Starry Messenger, about pointing the telescope to a fuzzy spot in the nighttime sky and then seeing that break up into individual stars. And then he sketched that. And it was probably this object and his publication of that as the first object that he did this to in the Starry Messenger that inspired a lot of other astronomers to really sit up and take notice of what he was doing and what might be available in the nighttime sky for observation.
That's very interesting. I did not know.
Yeah, that's kind of one of those things. And I have like an excerpt, the Starry Messenger there, and you can go and go into one of the online libraries and go through. But like when you read somebody like G.B. Hodierna's observations, he points to this observation and reading this in Galileo's notes as the observation which motivated him to start going on his own and getting a Galilean type telescope and hunting things down in the nighttime sky. And certainly it had that sort of influence on other observers as well, of course. Like that's kind of, I think, really what got the ball rolling. But these aren't just misty spots or clouds in the nighttime sky that are just fixed for some strange reason. These are actually stars, so they're not what they necessarily appear to be, at the outset. Interesting, eh?
Yeah, it is. It is very interesting.
But like even since before the times of the telescope, that had been logged as a misty patch. It was seen as one of these misty patches by Abdur al-Sufi and cataloged as such in Bayer 1603 Uranometria. And then just down and below, of course, this is a telescopic object, which is M67, which is sort of right between the center of Cancer and that weird little head of Hydra, the water snake.
Okay, cool.
Then moving on to Sextants, and like I said, with the small, low power binoculars, you can see pretty much all of Cancer. I think it pretty much just fits in the field of view. But with a pair of binoculars, like if you take any binocular and point it at the center of Cancer, you're going to see the beehive cluster, and it's going to break apart just like it did for Galileo. And then kind of moving down into the left or to the southeast, you're going to get to Sextans, the sextant, which was introduced by Johannes Hevelius in 1687. And it's a fainter constellation, but there's not much there, just one sort of bright-ish NGC 3115, which is a lenticular galaxy. And there's no star above fifth magnitude. But again, you have these fainter stars that form this roughly sextant pattern. And then to be able to take like a super wide field binocular, get out to a dark sky, and just to be able to identify that region and that pattern of stars is kind of neat. And then as well, like NGC 3115 is a lenticular, but it's also in the ecliptic. So like the moon and that, and the planets actually pass by it. There's also a good chance for comets to pass by 3115 as well. So good photographic opportunity if you get a comet in that neighborhood. Chances are might make a close approach.
Cool.
Crater of the Cup. Crater is neat. Again, it sort of has these weird sort of antenna type patterns that come out. It was listed in Ptolemy's Algemest as one of his 48 constellations, but that means it was likely cataloged by the Babylonians before him, and it has no star brighter than third magnitude. It's got a bunch of faint galaxies, but there's also the Eta Craterids, which is a faint meteor shower, takes place at the end of January, I guess the middle of January, between the 11th and 22nd. And then just has all these faint galaxies. But again, even though there's not as much to see there, like in a small telescope or from a light polluted city, just being able to ID those patterns, and that it's the cup that the crow was supposed to fill full of water to get for Apollo, I guess is kind of the interesting fact with it. And then we have Corvus the Crow, which is another Ptolemaic constellation. Brightest star is just 2.6 magnitude. So not very bright, but there are some interesting things here. I think the two really interesting things here are NGC 4038 and NGC 4039, which are the antennae galaxy. And these are pretty famous. Did you ever see those?
Yeah, I think one of our spring grassland sessions, I'd have to check my logs, but I think we observed it once or twice at least.
Yeah, I actually think that you and I went out to a site just east of the city and observed it through your 12-inch when you had it. I think I remember doing that one night, or maybe we were there with Mike, or maybe it was in the grasslands. But I remember we actually had observed that one together a number of years ago.
Yeah, it's a really neat object. You definitely need some aperture for that one, I think, but it's well worth the search.
Yeah, I could pick it up in the 5-inch, but it was just like a fuzzy thing. But in the 12-inch telescope, you could start to see that sort of unmistakable pattern. These are two interacting galaxies, and because of that interaction, there's a lot of disruption and merging of gas and dust and star birth and all this type of stuff going on. It's pretty cool. And then as well, one thing that's neat is right in the center of Corvus is NGC 4361, which is a planetary nebula. It's about 11th magnitude. It's not really bright, but it's neat to hunt down because it's almost like dead center in Corvus is not quite a square of stars, but it's sort of just like an off square of stars, and then almost just above the center of it. Yeah, just above the center of the square is this little planetary nebula, which is well worth hunting down. I've seen that in my 5-inch quite a few times. I always try to hunt it down most spring evenings when we're out. Then there's a couple of meteor showers that they found in Corvus. So I don't think any of these meteor showers are really that prominent, but this one of them they've traced back to one of the 11P temples with linear comets. But anyway, I'm not sure how visible any of those meteor showers are. But I mean, that's just kind of like a neat selection, I think, of some of these more subtly springtime constellations. Anything to add to that, Shane?
Maybe just one more thing about Corvus while we just finished talking about it. And, I think Corvus is kind of represented by that square or sort of trapezoid of, third magnitude stars. And you mentioned that planetary nebula right in that, probably almost in the same field of view or very close, is another long period variable, R Corvi. And it's nearly right in the middle of that trapezoid. It has a 317-day cycle, and it goes from magnitude 6.7 down to 14.4. Which is, probably out of view or out of range for most amateur telescopes. You definitely need some aperture to get it at its dimmest. Yeah. But if you're into variables, here's yet another one that will change its brightness over, close to a year, I suppose. But, if that intrigues you, start doing some variable star estimates with that one.
Yeah, I just looked it up. That's a Mira. That is a Mira type star, though. That's pretty famous one, I think. So very cool.
Yeah.
Excellent. Any other stars that have kind of struck your interest?
There is one in Corvus again, like another double star system that is like one of the showpiece ones. It is a visually matched 2+1 triple is how it's designated here. So the magnitudes are 5.9, 5.9, and 10.3. So the description here is it's a triple with an algo type detached eclipsing variable.
Oh, wow.
That's another interesting one to check out. That is Struve 1669.
Okay. Huh. Wow. That could be a pretty interesting one to track down then. All right.
Yeah, for sure.
Well, that's some interesting stars. Thanks for that. Any other ones that have piqued your interest?
No, that's all I have today, Chris.
All right. Well, we are getting towards the end here. So thanks so much for that, Shane. And thanks to everybody for listening. Be sure to subscribe in your podcatching software. And we're always excited to get your observing emails to actualastronomy@gmail.com. Thanks for listening, everybody.
Thank you, everyone, for listening, and we hope you enjoyed the show. If you are interested in more information, would like to contact us, or if you would like to support the podcast, check out our website, actualastronomy.com.